friends, in this video we are going to study sound waves. A wave is a disturbance that moves through a medium. The particles of the medium do not move forward themselves, but the disturbance is carried forward, as you can see in the GIF. This is what happens in the propagation of sound. Hence, sound can be visualized as a wave. Sound waves are characterized by the motion of particles in the medium. Sound waves are also called mechanical waves. Sound waves are formed there are two ways. First is compression. When a vibrating object moves forward, it pushes and compresses the air in front of it. This creates a region of high pressure. Thus, the compression starts to move away from the vibrating object. The blue lines represent compression. Rarefaction. When the vibrating object moves backward, it creates a region of low pressure. Red lines represents rarefaction. As the objects move back and forth rapidly, a series of compressions and rarefactions is created in the air, which forms one cycle. These make the sound wave that propagates through the medium. Pressure is related to the number of particles of a medium in a given volume. More density of the particle in the medium gives more pressure and vice versa. Thus, propagation of sound can be visualized as propagation of density variations or pressure variations in the medium. Sound needs a medium to travel. Sound is a mechanical wave. It needs a material medium like air, water, steel, etc. for its propagation. Sound cannot travel through vacuum. This can be demonstrated by the bell jar experiment. Bell jar experiment. Take an electric bell and an airtight glass bell jar, as you can see in the figure. The electric bell is suspended inside the airtight bell jar. The bell jar is connected to a vacuum pump. Step 1. Press the switch. You will hear the bell clearly. And step 2. Start the vacuum pump and pump out air gradually. The sound becomes fainter, means lower. When less air is left inside the bell jar, you will hear a very feeble sound, means very less sound can be heard by your ears. Sound waves are longitudinal waves. Take a slinky. Mark a dot on the slinky. Slinky is the pre-compressed spring. When the slinky is pulled or pushed, the dots moves back and forth parallel to the direction of the propagation of the disturbance. The waves produced due to the propagation of the disturbance in the slinky are called longitudinal waves, as you can see in the figure or you can see the GIF. The particles do not move from one place to another, but they simply oscillate back and forth about their position of rest. Transverse waves. In transverse waves, particles do not oscillate along the direction of the wave propagation. They oscillate up and down about their mean position as the wave travels, and you can see the GIF of the transverse waves. Direction of the individual particles is perpendicular to the direction of wave propagation. When we drop a pebble in a pond, the waves on the water surface is an example of transverse wave. Light is also a transverse wave. Light is also a transverse wave, but for light, the oscillations are not of the medium particles because it is not a mechanical wave. Characteristics of a sound wave. Figure A and Figure B represents the density and pressure variation of a sound wave propagates in the medium. The density as well as the pressure of the medium at a given time varies with distance above and below the average value of density and pressure. As you can see the figure below the figure B. Compressions are regions where density as well as the pressure is high. Compression is denoted by C in the figures. Rarefactions are the regions of low pressure and are represented by valley, and here R is represented as rarefaction. A peak is called the crest of a wave, as you can see in the figure, and a valley is called the trough of a wave. Now we will see wavelength. The distance between the two consecutive compression or two consecutive rarefaction is called wavelength. It is denoted in the figure given above. The wavelength is represented by lambda. Its SI unit is meter, means the SI unit of wavelength is meter. Frequency. Frequency tells us how frequently an event occurs in unit time. The number of oscillations per unit time is the frequency of the sound wave, as you can see in the GIF. Frequency is represented by nu and SI unit is hertz. Time period of the wave. The time taken by two consecutive compressions or rarefaction to cross a fixed point is time period. In other words, the time taken for one complete oscillation is called the time period of the sound wave. It is represented by the symbol T. SI unit of time period is second. Frequency and time period are related as follows. V is a Greek letter which is called as nu. So, nu is equal to 1 by time period. Pitch. How the brain interprets the frequency of an emitted sound is called its pitch. The faster the vibration of the source, the higher is the frequency and the higher is the pitch. High and low pitch. More number of compressions and rarefactions passing a fixed point per unit time having high frequency is high pitch. And less number of compressions and rarefactions passing a fixed point per unit time having low frequency is low pitch. In the figure, red line denotes high pitch sound, blue line denotes medium pitch sound wave, and the yellow line denotes the low pitch sound wave. Amplitude of the sound wave. The magnitude of the maximum disturbance in the medium on either side of the mean value is amplitude. Amplitude is represented by the letter A. The loudness or softness of a sound is determined basically by its amplitude. As a sound wave moves away from the source, its amplitude as well as its loudness decreases. Louder sound can travel a large distance as it is associated with higher energy. As you can see in the figure, amplitude, wavelength and phase is moving, and you can see a better example, and it is explained in this figure, the amplitude. The sound which is more pleasant is said to be of a rich quality. The sound of single frequency is called a tone. The sound which is produced due to a mixture of several frequencies is called a note. Noise is unpleasant to the ear. Now the intensity of sound. The amount of sound energy passing each second through unit area is the intensity of sound. Loudness is a measure of the response of the ear to the sound. Even when two sounds are of equal intensity, we may hear one as louder than the other simply because our ear detects it better.